Now see, this is an interesting problem. These two problems have close relations. A same working formula will deal with both these problems, but it will give different results. So let us see what happens. The question given is, calculate the wavelength of Broglie. The actual pronunciation is Broglie matter wave associated with. Now problem 5, you have to apply it on electron having velocity 2.05 into 10 to the 7 meter per second, and in the next problem, on a cricket ball having mass 60 gram and is moving with velocity 10 meter per second. And we have to see how this de Broglie hypothesis regarding the wave character, the wave nature of a matter, how it is related with a microscopic particle and a macroscopic particle. So this we have to see. Now, solution. So first we have to know the Broglie matter wave relation. The Broglie matter wavelength lambda is given by, this is h by mv. That is, wavelength is Planck's constant upon the momentum of the particle. Now for the electron, let us calculate it for the electron first. So for electron it is lambda equals to h, it is 6.626 into 10 to the power minus 34 joule second is the unit. Mass of an electron is 9.11 into 10 to the power minus 31 kg. We have to put kg here, and velocity is 2.05 into 10 to the power 7 meter per second. Now I have told you just now that don't put the power in calculator. So we have 6.626 by 9.11 into 2.05 here, and here we will get 10 to the power minus 34. This minus 31 will go up, so it will be plus 31, and this plus 7 will go up and it will be minus 7. So let us calculate this. This is 6.626 divided by 9.11 equal to, and again we have to divide it by 2.05. So it will be 0.35479. So the first part will be 0.35479 into what it will give us. This 10 to minus 34 plus 31, it will be minus 3, and minus 7, it is minus 10. Now see what happens to the unit. You see, this joule is Newton meter, and here we have kg meter per second and another second here. See, this kg meter per second here, kg meter per second, and joule is given by Newton meter, and second here. Now this second inverse will go up and it will give you second square. Now this meter will cancel out, so we have Newton per kg. Now Newton is kg meter per second square. Newton is that force which, when acts on a body of mass 1 kilogram, produces in it an acceleration of 1 meter per second square. So this Newton is kg meter per second square, and we have a kilogram at the denominator. So this kilogram kilogram will cancel, this second square second to the minus 2 will cancel. So it will be, or lambda equals to 3.79 into 10 to the power. Now see one thing, let us multiply it by 10 so that it will give us 3.5479. So you have to divide here by 10. So it will be 10 to the power minus 11 meter. So this is the wavelength of the electron as in problem 5. So this is the wavelength of the electron. Now for the cricket ball, the same formula is going to work as suggested by de Broglie. Only we have to replace these things. So don't erase in your copy, you have to write it from the, write it as a new problem. Now see what happens, let us see what happens. For the ball, lambda equals to h by mv. Now the mass of the ball is 60 gram. See one thing, this is in SI unit and you have the problem given, in the problem given we have the mass of the ball to be 60 gram. So don't forget to convert it into kilogram. Then result will be erroneous. So to convert gram into kilogram it will be 10 to the power minus 3. 1 gram equals to 10 to the minus 3 kilogram. And the velocity is given as 10 meter per second. So what it will have, 6.626 and 10 to the power minus 34 joule second. It will remain as it is. Now here we will have, see what we will get here, 60 into 10 it is 600 and 600 into 10 to the power minus 3 it is 0.6. So we will have this expression and we will get the unit as before. So again we need the calculator. So you have to put 6.626 divided by 0.6 equals to 11.043. It is 11.043. So 11.043 into 10 to the power minus 34, or lambda cricket ball equals to, we will write it as 1.1043. So this 10 will multiply here and it will give you minus 33 and we will have meter here. See, we are not putting the meter unit directly, we are deriving it. So this gives a better understanding of this working formula. So the wavelength of the ball is 1.1043 into 10 to the minus 33 meter and the wavelength of the electron is 3.5479 into 10 to the minus 11 meter. Now you can see the another part of the question, which is comment on your results. The comment is like this. This de Broglie matter-wave relation, that is the equation which represents duality, both the wave nature and the particle nature, is valid for both electron and for ball. That is, it is valid for both microscopic particles like electron, proton, alpha particle, beta particle, and it is also valid for macroscopic particles like this cricket ball, a truck, a moving truck, and any other macro body that we can handle, we can see. So the validity is general. De Broglie equation, matter wavelength, is valid for both microscopic systems and also for macroscopic systems. Now then, why don't we see a ball moving like a wave? The ball we see that a particle is moving and it 100% follow the Newtonian mechanics. So where is the discrepancy then? De Broglie is suggesting that the matter wave equation is valid even for a cricket ball. But you see, classical mechanics is defining the trajectory of this ball. So, and in our experience we have never seen a ball to move like a wave. So how it is valid in this case then? For electron we have no doubt, we have no objection. So electron behaves like a wave and it constructs the orbit of an atom through constructive and destructive interference, through constructive interference mainly, and for the destructive interference the truncation results, that is all orbits are not allowed. So here wave nature is manifested. Even we have not seen the wave nature of electron, just through experiments it is confirmed, but we have seen ball to move like a particle. But de Broglie is suggesting that matter wave is associated with it. So how it is valid then? You see, this is 10 to the power minus 33 meter. And what is the size of the ball? The ball is near about 6 to 7 centimeter in diameter. So in meter it will be 0.06 meter. 6 centimeter, that is 6 by 100. So a ball is 0.06 meter, about 6 into 10 to the power minus 2 meter in diameter. But the wave which is associated with this ball is 10 to the power minus 33 meter. So you have to divide it by 10 to the power 31 times more. So if we place the waves, if we try to draw the waves, what will happen? It contains, this length will contain almost this number of waves, 10 to the power 33 number of waves. In one, the wavelength of this ball is 10 to the power 33, 10 to the power minus 33 meter. So it is so much divisions of a meter. So what this ball will contain? A huge number of waves it will contain. So you have to calculate like this. In 10 to the power minus 33 meter there is one wave. So in 10 to the minus 2 meter how many waves it will have? So it will be 10 to the power minus 2 by 10 to the power minus 33. It go up. So it will be 10 to the power 31. So within this diameter there will be 10 to the power 31 waves. Can you imagine? Not 31 waves, 10 to the power 31, greater than the Avogadro number. So when we draw these waves, if we are able to draw this wave, it will give you the nodes and antinodes, the ups and downs, the troughs and the crests will coincide. So these waves will give you dot 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 dot. All the troughs and the crests will coincide, and it will give you a straight line. That's the trajectory actually we notice. So if we have to place 10 to the power 31 number of waves within this, so what will happen? This huge number of, very large number of waves, if we try to draw at this point, it will give us a straight line. We will not be able to observe the wavelengths with respect to this dimension. So due to this huge mismatch in dimension, it will manifest the particle nature. And obviously, it does not mean that it is not validating the de Broglie equation. It is with the wave nature, but the waves are so small that it is giving a linear trajectory, and we know that a particle follows the classical mechanics and it follows the trajectory, not that of a wave. Now for the electron, you see the dimension of an atom is near about 10 to the minus 8 centimeter, that is 10 to the minus 10 meter. It is the dimension of an atom. Now for the nucleus it is much more smaller, it is 10 to the minus 15 meter. And for electron it is much smaller, say 10 to the power minus 16 or that. But you see, it revolves around the nucleus and forms the orbit, and orbit plus nucleus, that gives you the atom. So the dimension of an atom, it is of the order of 10 to the power minus 10 meter. So you see, this value is comparable to this dimension. So here for this electron there is a dimension matching. So it guarantees that you will get the wave nature of electron. You will realize the wave nature of electron. And for ball, the dimension is not matching. There are waves, but you will be unable to realize the waves. So it is applicable, it is valid in both macroscopic system and microscopic system, but the effect is not realized in macroscopic bodies due to this dimension mismatching, but is realized in microscopic systems due to matching in the dimension. So this is the comment section, but in the problem it is given just only to calculate the wavelength. So this is all about these problems. Okay.